Making of a Metasploit module. Do we have any developers out there? Full-time developers? Raise a hand. No? Good. Do we have any Rapid7 guys? Also good. Do you have anyone who's made a Metasploit module? One guy. All right. It's my kind of crowd. I made a Metasploit module, and when I was telling people I made a Metasploit module, they were like, how do I make a Metasploit module? And I don't have a blog or anything at all. So I thought I would do a talk on it and the process that I took. Who I am not Rapid7. I talked to 2 Rapid7 people to tell them I was going to do this. And I got some stickers and some socks. And I'm wearing the socks. I'm not a paid developer, so definitely not paid by them. My name is Ringo. This is my Twitter, my LinkedIn. I'm in the Air Force at Keesler, where we have a kind of intro to cyber school where we teach people who don't come from a cyber background the basics so we can get them going doing offensive and defensive cyber operations. That's the end goal, but we're just the beginning. And I don't bug bounty much, but when I do, I synac. This project was my first time using Git for more than just pulling stuff down. It's made for collaboration, and I did not use it like that before. I would just clone stuff, maybe back up my own stuff. It was like a free backup service. And saying that, I know there might be a better way to do some of this stuff. That's just how I did it. What I'll cover, a quick overview of the framework, why you might want to contribute to the framework, my module in particular, the dev environment setup needed, just enough Git to get through it, pun intended, module testing, and putting in a pull request. What's Metasploit? Does anyone here not know what Metasploit is? And that's one of the reasons you might want to contribute right there. No hands went up, either because you're shy or whatever, but Metasploit is what we start our guys out with when we want them to be introduced to an offensive framework. It is what most pen testers, it's the first tool they usually use, and it might be the last tool they use because you can do a lot with it. Here's some other reasons you might want to contribute. When you make a module, when you start putting stuff out there, and even if you don't just make a module, just making things, making a blog, doing a talk, and you don't know where it's going to lead, because you make it, and the good thing about a module is you make it and you're done. It's not some project that you have to keep maintaining. I did my module, it's done. Now a future employer or anyone can go look at it and it's going to be there, and they're like, oh, this guy has some experience making things. And as I said, you don't know where it's going to lead. Mine, I got a talk out of it, and that's pretty cool. Free training. Nobody said they were a paid developer. How much would it cost to get core people from the Metasploit framework to give you training on the framework? Probably a lot. This is free. You just start working with them and they will help you out, and that's awesome. You learn how the sausage is made by making it. If you're an OCO guy and maybe say there's a new version of software out there, but the module that is in the framework it does not work with that software. If you know how it works, you can get in there, you can change it, and maybe you can get on that target that you wouldn't have been able to do before. So there's a lot of reasons to want to know how the framework works. More reasons to contribute. Low barrier to entry. This is modular code. It's very easy to use, and there's lots of example code out there. It's a double-edged sword because it's been around for a while. In 2007, they redid it with Ruby, and you might want to steal from the newer stuff is what I'm trying to say. There's a place for you. It's a very large project. They have things that they'll tag newbie friendly, so just starting out, and even documentation, stuff like that. Like if you read a module and it does not have, this didn't work in this situation, you can update that once you know the process of Git and all that. And Metasploit's up for it. This was OJ, who's awesome, complaining about people complaining about Metasploit. People would say, this doesn't work, or this isn't good enough, or what. Like, it is open source. You can make it the framework you want it to be. It's really up to you. Ask questions. There is the Slack channel that you can go to and ask questions of the developers, but you want to be in the contributor channel. In the general channel, what you're going to get is you're going to get guys saying, hey, I installed Metasploit on my Windows box, and I'm generating the payloads, and Windows Defender's eating it. Can you help me out? And unless you want to provide support for that, I would stick to the contributor channel. The IRC, who's HD Moore?
He is the gentleman that started the Metasploit project.
So, pretty famous. I think he's one of the top 10 most well-known hackers. They have an IRC chat. I went into the IRC chat, and for my code, someone had posted under it, they put, Jenkins, test this, please. And I Googled it. What the hell is a Jenkins test? How do I do this Jenkins test that this guy's asking for? And I could not find a solution. And I went into IRC, and I'm like, yo, someone said Jenkins test the code. How do I do that? What is that? And HD Moore is the one that replied and said, oh man, that's just like running some checks. It's automatic. Like they just type that under the code, and then GitHub will automatically test it to make sure it doesn't break the framework. That's like asking a celebrity where the bathroom is to me. So that was my brush with greatness. So you don't know what you're going to get. The IRC isn't as active though, because it's a lot of people with like their bots listening, and it just seems to pipe up now and then. Metasploit directories, if you haven't looked at them, or even if you have, here's a refresher. The lib is where the libraries are. That's where the magic kind of happens, because you can import these things and bring them into your code, and it will do what you need to do. Like if you want to put a file on a system, there's something called file dropper, and you just make sure that it's there, and then you can drop files on a system. Modules, this is where all your code's going to actually go. Encoders, nops, payloads, post, auxiliary, exploits, that's where it goes, along with the documentation and stuff. Tools, that's more for exploit development, like buffer overflows and stuff like that, but there is some other stuff in there that can help you. I kind of didn't mess with that much. Plugins, this is where the stuff is that extends the Metasploit framework. So as an example, if you wanted to work with Nessus or something like that, that's where you'd put the plugin. Scripts, this is where the old stuff was. If the good reason about to know this one is that the code that is there, it's the original module, so to speak. So a lot of the popular stuff is in that scripts folder, but it's like super old code. You do not want to be stealing from there, and they don't let you contribute to the scripts folder anymore. Everything's in modules. But that's where it is. So if something's broken and it's old, it might be in that folder is what I'm trying to say. My first module, Xorg Privesc. Xorg is a setuid program, and the Privesc was where you start Xorg, which will give you a desktop to look at, and you could pick where the log file was going to go. And the thing about that is, since it's SUID, it's running as root, you can overwrite other files on the system. And you can tell it something that's incorrect. It's displaying something. You could say, I want to display the frame size of my exploit code. And it will write your exploit code to the log because that is not a valid frame size or whatever. So that is how you get your code into the file that it's overwriting. And there was a couple ways that people were exploiting this. They were overwriting password, which is super sketch. And then I saw that some gentleman had overwritten the cron tab. And that seemed to work. It didn't really crash anything. And so I was like, I like that one, but I want to see what Metasploit's using. So I went to the GitHub. I didn't see anything. There's crickets for the code. I looked in the PRs, the pull requests. That's where the people put the code that they want to integrate into Metasploit. Nothing. And I thought to myself, well, I should make it. And I did. I spent about 4 hours making and testing a module. Now that's from setting up the dev environment to building a test box. That's how quick it was. The sad thing about it is I was like, oh, so now I have it. I'm going to try to put it in the project, because that'd be cool, because I'm an instructor and I could tell the students like, oh, type my name. You're going to come up with the module. How cool is that? But when I first failed at putting it on GitHub, which was great. It's okay to fail. I learned a lot. And I finally got it up there, and then I had 100 comments. But they weren't like good comments. They're like, you could totally do this better if you did this. But they were constructive. But there was a lot of them. It was just a barrage of comments. And I learned a lot. They're pretty helpful. I'm looking at a module. They have a simple layout. Copying will bring your work down. This is how kind of I was able to do this whole thing in 4 hours. Now, notice I didn't say that that was the completed module. That was my initial submission. It took a lot longer to get a completed module. But you can copy. You can just look for something that is similar to the code that you want to do. I wanted to do a PrivS, so I looked at other PrivS codes, copied over one of those, renamed it mine. I like that comic. This is mine. So that's what I did. Ruby. I told people I made a Metasploit module. And they're like, oh, you must be awesome with Ruby. I do not know Ruby. I know Python. So when I looked at the Ruby code, I was like, well, this is kind of like Python. And then I kind of just stole the rest. I don't know. You can do external modules in Python and in Go. But that is constrained because there's less examples and you cannot do all of the module types with those. My approach was the grep and steal approach for most of it. I would know kind of what I wanted to do, and I would just grep across all of the stuff for code that did something like that, and then I would just integrate it into my module. But that came with its own little challenges, and also a kind of funny story. There's something you can do called WFS delay, and what that does is it will make your listener start after a certain amount of time. And B. Coles, who is the gentleman at Rapid7 who helped me make this module, he mentored me. He said, oh, you're going to want to use that. And so I went to my grep approach. I wanted to see, well, how has someone else used this? And I grepped, but instead of WFS delay, I typed WSF delay. And I hit enter. Guess what? 2 hits, which is really low for something that you'd think be popular. And I started reading through the code to see how they had used it, and there was a comment. And the comment said, this sleep thing don't work, or something like that. Because they had typed it wrong when they made the module, and somehow that module got past everything and was in the framework. So by just looking, I was able to help find and fix another module because I typoed something. That's kind of interesting. A basic module structure, you're going to have whatever libraries you're importing at the top, and then you're going to have the information about the module. You can just pull them up and look at them. They're pretty easy to understand what's going on. Most of the module is just that top information part. That's like putting what it does, your name, CVE, and it's all mostly boilerplate. So when you steal it from something else, you just copy it over, make a little skeleton, fill in your information. That is most of the modules. When you look at the modules, there's not much code under them. It's almost all just that what is this and what does it do? Because they're modular, they're importing a lot of the other code from other places. In some of it, there's a check section. That's to make sure that host or whatever you're throwing it at is vulnerable. But that's not in everything. There's also an exploit run section, and that's where the meat and potatoes is of your code. Now, I said I did not know Ruby. I picked some stuff up. I mean, I had to get it to work. I learned what a data store is. So when as an example, you might define something up at the top, a writable directory. I could do a writable directory of my data store, and then someone would come into the module and they would set that writable directory, and I could access it through this data store part. So I could make a variable equals data store, and then whatever that option was that I defined above. So this would be data store writable directory. Maybe I'd assign it to a variable called writable directory. Then I learned about string interpolation in Ruby, which is similar to Python's f-strings because, like I said, I know Python. So that's kind of how I did that. And you just, it needs double quotes. So you just need double quotes, and then you put a hash and braces, and then your variable name, and you can fill out whatever you want to put there. And then instance variables. If you want to pass a variable between different methods, you can put the @ sign on it, and then you can just pass it around. The thing that you see with Ruby code is there's a lot of ends. You're like, wow, there's a lot of ends in this code because you end all your blocks with end. And command exec was actually a bulk of what what I needed to do. This is just running code on the system. any kind of code you wanted, like you could make a basic module that just ran whatever code you wanted on the system with just command exec. So fill in the top part. I want to run this code, command exec this code. That's pretty much a module. Going over the initial dev setup, they have this very well documented at this short link. I recommend using Ubuntu. You can try Kali. I had gem issues with Kali, and I don't want to get into that. But Ubuntu is very nice. It's straightforward, and that's what they use in the example, so I would recommend that. And the good thing about when you start working with the GitHub source, and you get write access to those exploits and stuff that people are using right now. So it's kind of nice just to have that. You don't have to wait for the next Kali update, because Kali manages the updates for the Metasploit framework. If you're doing it straight from GitHub, you get the hottest hotness. And then what you want to do is you're going to want to go ahead and fork the code, which is going to copy the Metasploit code to your code on GitHub, or your repository. This is a reminder. I creeped a lot on their PRs and stuff like that, and I saw common issues that people would have, and I actually did this once too. I've done more than one module since this. MSF Tidy is a tool that you can run on your code, and it goes through and it checks for extra spaces and stuff like that. And in the instructions, it says to set up something called a Git hook. A Git hook is whenever you run your Git commit or whatever, it will run the code that is in that Git hook. And MSF Tidy will run by default. So when you put the code up on GitHub, you're automatically checking it. And what people will do is they'll just forget to do that. And then they'll put up code with a lot of extraneous spaces and just common errors with it. And the first thing the Metasploit people do when they look at your code is it's going to get ran through MSF Tidy. So they're going to be like, hey bro, you didn't run MSF Tidy. And you don't want to be that guy. So make sure you get this part right. Some basic Git commands. Git clone, this is the one I was familiar with. This is where you just copy down all this stuff. Get checkout with the attack B and a branch name. So there's the master, and I have a visual diagram kind of this process next, so don't get too worried if you haven't really messed with this. Get checkout with a attack B will create a branch under the master. You don't want to work in master. That's the main code. Everything you're doing is going to be in a branch. Get status is going to show you the branch that you are currently in, along with any files that you've modified and that will be saved. Get add is going to add stuff to being tracked, and you'll see that in your get status. And get commit is like saving. It's equivalent of saving. And the M is the message, like I added this, and that's going to be saved. I put this one in here. I don't know if I'd recommend it. I got a warning sign, but man, I used it a couple times, so this comes with a caveat. Be careful. You can do something called a rebase. If you like to save a lot, like maybe I added period, added colon, like every time you save it and you don't want to have that big mess of saves, you can do a rebase which takes all your saves and it puts them into one big save. So you're kind of overwriting history, and it's kind of dangerous if you go back too far, because then you start getting into other people's code. So make sure you have the right number there if you want to do that. And then the git push is how you put your code onto your repository code. And I have the branch name. So this is going to be get push origin, which would be your repository. It's just going to be the origin. And then the branch name is going to be whatever your branch is. Okay, here's my visualization. Mostly you're going to be over on the right, where you're going to have, it's just your local dev box, and then you on GitHub, and you're just going back and forth. And then you're going to get to a point where you're going to do your pull request, which is where you're going to try to integrate your code into Rapid7's code. And hopefully that works out for you. But, yep. And I'll put these up somewhere, probably on Get, because I can use Get now. So I'll probably put these slides up there, so if you're in the back, you can't see. But once you've done that, you're going to want to test your module, because how embarrassing would it be to put that code up and then it doesn't work? So you're going to make sure that you at least contribute code that's working, because I don't know how much I would want to help someone if they contributed the code and didn't even work at all. But here's some of the things that I did. I use reload a lot. If you're in MSF console you can type reload and then whatever the module is you're working on, and it will reread in the code from that module. So what you can have is you can have a window with MSF console, and then you can have another window with VS Code or the editor of your choice. You save the code, you reload the module, you test it. Make some change in your code, reload the module, and test it. Otherwise, it's not going to be automatically updated because when MSF console starts, that's when it reads in the code. If you're changing multiple modules, you can do something called reload all. And this also goes if you were to go on GitHub and pull in a module. Like if you just wanted to use that module, you can reload it. I set up a grouping for my VMs because I tested on multiple operating systems. This made it easy for me to start and stop all of them. You could do some cool things like maybe have a listener already going on all of them, but I didn't. I like to freshly exploit them. And I use RC scripts to do that. An RC script is a way that you can automate that MSF console. And I have an example of one of my RC scripts that I would use. As an example, it would start the SSH login. I would set the L host, the R host, and these are static IPs. And username creds, whatever. Exploit, I would get it. I would have a session. It'd be session 1 because I just restarted the box. And then I would set verbose to true because I need to see them errors. And there will be, with me, there'll be errors. Initially. And then it'll get ironed out. And then to start the MSF console and run all these commands, it was MSF console, tech R, and then I had a RC for each one of those boxes. So I'm like, oh, I want to test on my CentOS box. Tech R, CentOS. All of a sudden, I have my session, I'm right there, and I can just hit enter, exploit, and I'm good. This is pretty cool right here. There's a built-in debugger. Did you guys know this? Pretty neat. I use this because while verbose errors is nice, I was able to type PRY. It took me into the debugger, and I was able to see the exact line where the error was, which I wasn't able to see through the normal process. So this helped me really narrow down my bugs. Okay, now we're getting to the pull request. You go to Rapid7, you go to the pull request tab, you click it, and then you have to compare. And you choose your repository and your branch. You're going to want to make sure when you put in that pull request that you have everything in there that you need. As an example, I see a lot of people miss the documentation because you should document kind of what your stuff does. So go ahead and put it in there, make sure it's in the branch so that when they get it, they don't have to ask for it because they'll tag it. Needs docs. You don't want to get tagged. You just want to kind of fly through. So go ahead and make sure everything's in there. And then the last part is waiting for feedback. This is probably the hardest part for a lot of people because you put your heart and 4 hours into an exploit module and then you put it up there and you wait because they're a small dev team. They're not huge. And if you pick an exploit that is saved to a mainframe or something that isn't in everyone's VM stash, they're going to have to build that box. Oh, I made this exploit for an Active Directory 2008. Like, they don't have that. If you want them to be able to test it, be prepared to wait. Or maybe provide the environment. I don't know, but that's kind of what happens. But document how to test it, so make sure you have everything that they need to do to make sure that they know that your stuff is working correctly. And then keep the faith. You just kind of wait. And that's pretty much it for the most part. Rapid7, especially B. Coles, helped me a lot in making the module. And NolaCon for having me. Pretty neat. Any questions, really? No? Cool. Thank you.